Hello and welcome. Sit tight. Catch Dog Concepts will be live very soon. Thank you for tuning in. Catch Dog congregation. What do you say? Ushers, close the doors. We have David Ishee in the building for a part 2. How you doing, sir?
Hey, how's it going?
All right. Part 2. We're gonna get right into it. So I had a couple questions I had left from before, but I mean we really got into some of the ones I had lined up before. So we're gonna take a step back into those. So let me see. So talk about your work with bioluminescent animals.
Sure. So I guess that's kind of where I started with the whole biotech genetics thing. What really started me was I guess right at 10 years ago. It was 2015. I saw a TED Talk about sort of where we are in genetic engineering, like where the tech is right now, or I guess where it was 10 years ago. And I was like, wow, this has come along a lot farther than I expected. And this is clearly where we need to go with dog breeding, right? And everybody thought I was crazy, but I thought I was crazy for a little while. But the more I got to learning about it, the more I realized this is really actually feasible. Just really, really hard. And so to start with, I needed to do a proof of concept. I mean, the general idea is if you can do genetic engineering, you can create a dog you could only dream of, right? And you have access to genes way outside just the dog population. And so that's when I started with the idea of, okay, I'll make a glowing dog, because scientists have made all sorts of things glow, right?
That's crazy to me. I've had people talk about this like before. Guy, my mentor, the dog guy, aka the coach, he's my mentor. Shout out to him, man. But yeah, he talked about it. He was like, man, this is guy. He's talking about glowing dogs. I was like, yeah. And then that next week, I got him on, Mr. David Ishee.
Yeah. So glowing dogs. So bioluminescence turns out to be hard in a mammal, like extra hard. Obviously, so I simplified it down after a couple of years to fluorescence. So fluorescence is just glowing, but it's the difference between like you turn off all the lights and it produces light with its own internal chemistry, and you shine a black light on it and it glows, right? So fluorescence is a lot easier because it's one gene. And so I'm like, okay, I'll bring it down to one gene, do fluorescent dogs. And worked on that for a few years with a process called sperm-mediated gene transfer, where you actually put the new DNA in the sperm instead of in the egg, which has worked in pigs and other animals, but nobody's ever done it successfully in dogs. And my overconfident self decided I'll figure it out in my shed. So I spent many years working on that, and now like it's my day job is making animals glow, right? So so that's what I do at work. But it's a the company I work for, that's our whole thing is making genetically modified animals that are different, something that's never been before.
Right. I'm sure you get like, I know you post a little bit about it. You don't post it too much. I'm sure you get like, oh my God, they're going to make another Jurassic Park or something, something like that. And I mean, I think about that, but I mean, in a way, it's just a amazing way to show how we've come so far from, I mean, breeding back in 1800s, 1700s, back then, even farther to now. And it's just, I mean, we just gonna keep getting better as time goes on until the man up there says it's time to shut all this down.
And that's what I tell people. The best dogs ever bred are in the future, you know?
Yeah.
And we just had to get there.
You said that last episode. I agree though. Yeah.
Yeah, and I think last time we even talked about direwolf DNA before this
Yeah, we
announcement
did.
even
We
came out.
did. Yeah,
Yeah,
we definitely did. We're gonna get into that also.
yeah.
Niall C actually said like the platypus as far as the bioluminescence.
So they're fluorescent. So they're not bioluminescent, but they are fluorescent. Yeah. So there's definitely North American flying squirrels are fluorescent. There's a handful of fluorescent mammals in the world. Yeah.
Okay. So I mean this is on topic. So he said, does he make the glow with algae DNA?
So there's a lot of different species that have fluorescent proteins. The classic one is a jellyfish. Everybody uses jellyfish DNA, but lately I've been working with copepod DNA, which is a tiny little microscopic crustacean. But there's coral DNA. And corals are red fluorescent, where the copepod is green fluorescent. So you can kind of pick your species to get different colors and things like that. And then there's engineered versions of those proteins where they can make them brighter or slightly different colors and all sorts of things.
Okay. All right. So why has it taken so long for us to be able to transfer eggs like we do with humans and livestock for dogs? What are some of the benefits that will come with that once accomplished?
So I mean, it can be done with dogs, but it took a long time. Like there are humans that are older than me that are walking around that were made by in vitro fertilization. So like test tube babies, right? So you take sperm and you take an egg, you put them together under the microscope, and then you put them in a person. That works really easy with humans for a lot of reasons, and other species. But dogs are particularly challenging for a few reasons. Dogs weren't done successfully until 2015.
Okay.
Um,
Yeah, I wasn't
because
caught up on that. I
yeah,
wasn't sure. Okay.
yeah, and so it's really new. But for a lot of reasons, one, dog sperm are unusual in a few ways. So even though we do artificial insemination all the time, and so like sperm extenders and all these sorts of things are really well worked out protocols. Some of the things that you need to do with a process called capacitation, where the sperm are actually so you think about where sperm live in a dog normally, they're just in the testicle hanging out. Yeah. And they can hang out there for months at a time, right? But once they come out, they've only got a couple of days in them because they activate and they get into this really highly active state where they're now doing their job. They're not just kind of like sitting there swimming in slow motion, not burning any energy. And you got to remember, sperm aren't really full cells. They can't repair themselves. They can't fix things when they're broken. So they just kind of go into like chill mode. And then when it comes time for them to actually fertilize, they go into hyperactive mode and they go out and they hunt down an egg and they fertilize. And that burns through their life really fast.
Right.
That process is called capacitation. And there's a lot of chemistry that goes on in that. And in dogs, it's unusual, like the amount of magnesium and calcium involved. And the pHs are very specific because dog vagina pHs are different than human ones. So the solutions that you use have to be different. And all the different chemistry involved is very complicated. And then the eggs themselves have a lot of like lipids. So basically a lot of little fats in there that make it very dark. So trying to see what's going on under the microscope with a human egg, it's like clear. You can see all the little structures. You can see the nucleus. You can see everything. It's really nice. But with a dog egg, it's really dark. And so it's hard to see what's going on. And so it's just harder. And dogs are the only mammal that releases immature eggs that mature in the fallopian tubes rather than mature eggs that are ready to go as soon as they're released. Wow. So that makes it even more complicated.
Right. Okay. Wow. That's interesting. Okay.
So there's just some technical hurdles that had to get gotten over.
Right. Right. That makes sense. Okay. So let me see. So what are some benefits that come with gene editing? And I mean, what level can it take breeding in just current animals up today? What level can it take them to?
So right out of the gate, eliminate all genetic disease. I mean, that's relatively straightforward. Most genetic diseases are, if not characterized, like if we don't know what the disease is, like what the cause is, you know, genetic engineering is one of the good ways to try and figure that out. Right. So for example, imagine I have a population of dogs that has a disease, and it's clearly something they get from their parents. If you breed two that have it, all the puppies have it. It's clearly genetic, but you don't know what gene So what you can do is you can just do gene sequencing of the sick ones and gene sequencing of the not sick ones, and you're going to get a small number of genes when you compare them that are different. And so what you really want to do is get like litter mates where one's sick and one's not, and you compare them, so there'll be fewer genetic differences. And in that set, there will be a few genetic differences, and one of them, or maybe more than one, will be responsible for the disease. But you can't be quite sure. So one of the things you can do is you could take something like a mouse, and you could make that same genetic change in the mouse, or even in a frog or some other species. And if that disease then pops up in the mouse, well, then you know this mutation causes this disease.
Right.
And then you can either reverse that mutation, or you can make a test and just screen against it. So you can just test all your puppies and see who carries for it.
Right. Wow. Okay, it's very interesting.
But all the genetic diseases right out of the gate. But that's just the first thing. That's just the low hanging fruit.
Yeah.
So beyond that, you've got any traits you can imagine that you would want to move from one species or one breed of dog to another breed of dog, or any canine that you would want to put it in there. Whether that's
like heat tolerance. I mean, or just better breathing. And wow, okay,
yeah, or the shape, or the color, or the morphology, or the way
density, all that.
Yeah, there are some things that are difficult, right? Some things that are fundamentally difficult, like blue eyes, for example.
Right.
The blue eye mutation happens because there's a like 1.2 million base pair duplication. So there's just this huge chunk of DNA that just got doubled. And so we don't have the technology to put a piece of DNA in that's that big. It's just too big. So we can't do that. But little things where it's like one or two pieces of DNA different or something, easy. And then anything we've done in research animals, like in mice, you could probably do in a dog also. That's all sorts of things: cancer resistance, super athleticism, all kinds of crazy stuff we've done. Things that you can find in other closely related species, like the big cats or the bears, things like that. You can take traits from them and put them in there because they're all carnivorans. But you can honestly reach a lot further out. You can grab probably any animal and move traits around. It just gets harder and harder the farther away you do, because you might have to make more and more adjustments.
Wow. Okay. Talk about some of the things you know has been done with the mice as far as like research or like even just test and has been successful.
Oh yeah. So they've done some, like they did one where they made some changes to their metabolism that made them super athletes, like in crazy endurance. Like they can run for months and weeks. I mean, I'm exaggerating, but like they can just run and run. And I mean, they did tests where they put them on treadmills that they can't get off of, right? And so they either run or just get like slammed up against the wall or dumped in water or something. Yeah. And so they can, like the other mice will just give up and be like, I guess I'm going to die. And these mice can just go and go and go and just endless stamina. The side effect of it is they were crazy aggressive. So I think they were just, because their metabolism was like turned up to 1,000, they were just hangry all the time.
Yeah.
So I don't know that we necessarily want that one, but you could do stuff like it, and things where like bone density has been increased dramatically. Size has been played with. You can make them live longer. You can make them cancer resistant. You can make them you can change the way their immune system works so that they're immune to infectious diseases. They've been made super muscular and things like that, with like follistatin overexpression, myostatin knockouts and things.
Wow. Okay. Man, I mean, we got incredible mice.
Yeah, totally. Mice. The problem with science is what you want out of a science lab. You're an academic lab, right? You work at university or somewhere. What you want to do is write a paper.
Right.
So you make all these super mice, and then you write a paper about it, take all kind of detailed notes, and then you kill all the mice. And at the end of the day, there's nothing to show for it but the paper.
Right. Yeah. Okay. So let me see what I had to say. So with all these new tools and studies we as humans have come upon, and the things you've learned through the years, if you would, how would you redo your program?
That's a great question. So Starting from the beginning with what I know now.
From the beginning, I mean,
Achilles,
all that.
Yeah, I would.
I got him.
So
y'all.
I would probably. You did. I would probably start. I might start with similar origins. I mean, I think I would follow the same general breeding philosophy of find greatness and breed greatness where you find it. Don't worry about the specific breeds. Just seek out greatness. But with what I know now, I could do a lot more with trait analysis. So even without genetic engineering, which has a bunch of legal consequences, if you're selling genetically modified animals, at least in the U.S. So what you can do is you can do a lot of genetic screening. And you can say, okay, this dog has this trait. This dog carries for this trait. So you can say, okay, these two dogs both carry for this trait. And I want that trait in the next generation. So I'm going to put these two together instead of these two. And then I'm more likely to get that. And then you can track and lock things down. So I think that would have saved me probably 5 years easily.
Wow.
Rather than having to like do so many test breedings and then get what I get and then record everything and just sort of like figure everything out. Because you know what you see in the dog, but you don't know what they have under the hood, right? You don't know what they're caring for.
Right.
Now, once your program is long enough and you know their parents and their grandparents and their great-grandparents and their great-great-great-great-grandparents, I mean, you can really start to get a sense of what's under the hood. And that helps you a lot. But that just takes a ton of time.
Yeah.
But you can also just scan them. I mean, you can just have their genes read to you. You take a swab, send it to a company. You get genetic data back, and you can just look at that and say, okay, this trait, this trait, this trait. And they don't have everything. They don't know how to check for everything.
Right.
But they can check for a lot of things that are useful. A lot of health data, which is super useful because then you don't have ugly surprises you have to fix. And then a lot of stuff where you can say, okay, genes for this and genes for that and genes for this. All these are under the hood. And I think people kind of understand that what makes a good dog is good genes. And so if you're a dog breeder, that's your whole bag, right? It's like you got to find the best genes you can, put them together. And you got to do it in a way that makes sense, right? Because you can't every combination of things, even if it's good on its own or it's good in some other combination, they don't necessarily work together, right? So you can end up with dogs that have traits that just don't make sense together, right? So you can have a dog who's bred for like speed and stamina, but he's got the legs of a corgi, you know? I mean, like, okay, he's fast, but his legs are this long, so he's not fast. So, you know, you got to do traits that make sense. And a lot of the complicated stuff is in the mind of the dog, and that's where I think a lot of people struggle is to understand the mind of the dog, so that they understand, you know, the drives of the dog, the confidence, the nerves, all the different things that are involved, especially in a working breed, that tell you, or that sort of create the temperament, right? So temperament's not one thing. It's a bunch of interacting factors. And you can get one thing totally out of balance and it'll just throw off the whole thing. And you think that dog's crazy. But really what you've done is you've just mixed 2 or 3 different things that probably shouldn't have been mixed together.
Right. Okay. Is there anything else you wanted to kind of touch on that subject as far as restarting, or even if you had a chance to redo your program?
Yeah, I mean, if I had the chance to restart, I would have the advantage of the fact that Midgards already exist in the world, so I'd just use them. But also, you know, a lot of other people are doing great work nowadays.
Yeah,
I think the biggest thing, if I were starting right now, that would help me isn't even necessarily genetics, which is big, but I think it's more about the changes that have happened in the philosophy of breeders, especially band dog breeders, in the last 10 years.
Right.
So many more people have come along to the way of thinking that like work matters and function over form and selecting for practical reasons and not just sort of breeding because it felt good and then retroactively coming up with some sort of explanation for why you thought that was a good pair.
Right. And I think some people, it's just like the word band dog. I mean, I think some people throw work around, like the term work, they working. Like, I don't say you got a spring pole up, and then they jump and get the spring pole. Oh yeah, he's a working dog. I mean, There's no pressure put on
Yeah.
that dog. There's no strenuous activity or strain on his brain trying
Yeah.
to figure out something. Just the simple things that come with the term work.
Yeah.
I think a lot of people throw that around and people get caught up in that. I'm like, oh, they're working dogs. I'm about to buy one. But they don't really understand what a working dog is.
Yeah, and a lot of people also, even a dog that will do man work, like a dog go charge a guy with a suit and try to tear him apart, still isn't necessarily a dog that you want,
right?
Because a dog can work for a lot of reasons. A dog may be working out of pure, just over cranked rank aggression, right?
Yeah.
And if you look at that dog sideways, or you're having a down day, you got a cold, the dog's like, he seems weak, I'm taking over, and the dog just attacks you. Nobody wants that.
Yeah. No, definitely not. And I mean, that's an issue. I don't want to point out any breeds, but you see that with some breeds. I mean, Rottweilers, they're ranked dominant dogs. I mean,
Yeah.
And their stigma's put on a lot of breeds too with that.
Yeah. Yeah. And I mean, it's the kind of thing where, you can get the same looking thing to an untrained person,
Right.
Dog bites the sleeve, dog bites the man, from a lot of different sources.
Yeah.
Whether that's prey drive, defense, just obedience. Dogs will bite sleeves as a trick, just as a thing that they're trained to do.
Yeah.
They do it on movie sets all the time. Dog doesn't have a bit of aggression in him, but he knows that if he bites the sleeve, he'll get his toy and praise, right?
Yeah.
That's his trick.
Most definitely.
So dogs can be trained to bite a sleeve for a lot of reasons, but not all of those reasons translate to a dog you want to live with, that will bite a man who kicks your door down and is brandishing a gun, right? I mean,
right.
It's a complicated thing that you really got to study and understand.
Right. I'm gonna ask you this. I don't want to get you in trouble now, but so where do you think some of the band dog breeders? I mean, you're still a breeder today, but what do you think some of the band dog breeders go wrong as far as either breeding methods, how they promote their dogs or brandish their dogs, and how they I said let's just start with that. Let's just start with that. Brandishing their dogs and how they breed them.
Yeah, so I think the biggest mistake or let me put it this way. I think the number one mistake that breeders in general make, and that band dog or designer or mixed breed breeders make more often, is not breeding towards a consistent vision over time.
Right.
So imagine you go 3 generations breeding in one direction, and then you kind of change your mind and you spend another 3 generations breeding back. Well, now you spent 6 generations breeding nowhere, and then you spend another 3 generations breeding over here, and then you breed over here for a while, and you just sort of wiggle around and you never really change anything. And so the dogs are just sort of kind of the same, nothing in particular. You want to get sort of like a direction and stick to it. You create a vision and you focus on that for generation after generation after generation. You pick the dog that's the most like that vision every generation, over and over.
So would you go as far to say, not to cut you off, so would you go as far to say like maybe even like a set standard, or not even as far as just a standard, just kind of like something like a height or maybe a weight where you want it to be average?
It doesn't necessarily have to be a physical thing, right? It could be a temperament, it could be a drive, it could be an outcome. Like you could say, I'm going to breed a dog that can run 45 miles an hour. And every generation, you clock those dogs. Like this one ran 42, this one ran 41, so I'm breeding 42. And then next generation, some of the puppies out of 42 ran 43. And you just keep going. And every generation, you're creeping towards your goal of 45. And so whatever that goal is, whether it's a functional test, a standard type, whatever it is, even when you're breeding plants, right? You're breeding tomatoes. You want a tomato this big. Well, you got to get the measuring tape out and you got to find out where you're at. So you test and you correct and you just minimize your error. So every generation, you're just wiggling towards your goal and you get closer and closer and closer every time. And if you stay consistent for decades, you get there. And that's the thing that people don't do. They don't stay consistent. They'll be like, man, I'm all about prey drive for generations. They go over towards prey drive. And then they're like, man, this prey drive stuff is for the birds. I'm all about size. And then they're breeding for size for generations. Prey drive kind of falls off. And they're like, you know what? I'm all about this. And then they breed for that for a while and all. And they never really get anything extraordinary. They never get anything unique or different or meaningful or like elite in any way, because they're just breeding for short periods of time for different goals, or they never really have a goal and they're just breeding what they like in the moment. They're like, man, this dog is so tough, I'm going to breed this dog. And then they breed another dog because they like how agile that dog is. But the two dogs together make dogs that are neither that tough nor that agile. So you gotta have a very specific vision in mind for what you're trying to create, and you push towards that consistently and steadily, and focus and focus and focus, and that's how you get stuff done.
Right.
But so that's the number one thing I see with the breeding side, is whatever specific methods or breeds you use or anything like that, it's all about focus and consistent selection. The other thing that I see band dog breeders mess up a lot with marketing is talking shit about other band dog breeders.
I don't even think that's just band dog breeders, but yeah,
totally.
That can hinder you.
It's breeders all over the place, because what happens consistently is if you talk shit about somebody, even if you don't like their dogs, but it's not your business, you start talking shit about this other breeder, and then they're going to start talking shit about you.
Yeah.
And then their buddies are going to talk shit about you, and your buddies are going to talk shit about them. And next thing you know, that's all you're spending your time doing, is talking shit about each other, and you're not out there doing anything with your dogs.
Right.
And you feel bad, they feel bad. Customers come along and they're like, let's find out about this kennel. And they just see a bunch of shit everywhere, just all over everybody. But if you just don't engage in that and just focus on doing good work and just stay true to your message, just this is what I'm producing. Either you like it or you don't like it. And this is what I make, because this is what I make.
You'll go for it. You'll go for it that way, I think.
Yeah. And nobody bothers talking shit about you because they got other people to talk shit about, because those people are slinging shit at them.
Right.
Like, nobody really goes out of their way to talk shit about me because I just don't engage.
Right. I mean, that's a simple way to do it. I mean, I think everybody should put that in their notebook, no matter if you're creating content and doing dogs, or even just breeding. I mean, you post pictures of your dogs no matter what. Just I mean, stay in your lane, stay yourself, and stay true to what your purpose was when you first started.
Yeah. Totally.
What was I gonna say? Talk about maybe I bit my tongue. I'm sorry. Talk about some issues that may come. No, it's pros and cons of let's dumb it down to even just the same breed, but maybe a different line, which is a little harder to talk about. But I mean, we can kind of talk into that. And then even crossbreeding with different breeds. Talk about some pros and cons that come with that.
With outcrossing, basically.
Yeah, yeah. That was the term I was looking for. Yeah, thank you.
Totally. So outcrossing has some so in terms of population health, the health of the population, not the health of the individual members of the population, because it's an important concept to get two separate ideas. So you can have healthy members of a population, and then you can have a healthy population, right? So the healthy population has to have genetic diversity, right? It can't just be a bunch of clones. You can have a bunch of healthy clones, and you have a population of healthy clones, but it's not a healthy population because it can't really grow, it can't really diversify, it can't adapt to its environment. And if anything comes along and adapts to it, right, like a disease, it can wipe out the whole population in one go. And so having genetic diversity is good on just the level of having a healthy population. And that's why issues like Dalmatians all having hyperuricemia pop up, because they're all descended from a very small population.
Let me stop you for a second. What is hyperuricemia? Can you kind of talk about it?
Yeah. So hyperuricemia is a genetic disease that Dalmatians have and a few other dogs, but Dalmatians all have it. So it causes them to build up a lot of uric acid.
That's right? What I thought. That's what I thought you was talking about. Okay.
Yeah, and it makes crystals in their bladder, and then it can't come out their urethra, and their pee will just back up behind it until the bladder explodes.
Oh wow!
So they have a surgery they'll do where they cut the base of the penis so they can pee out of the back of the penis instead of the front. So it's a shorter path, so they're less likely to get clogged. So,
right.
Yeah, but it's because this one protein is broken, right? It's called SLC2A9. So it's a solute carrier protein, right? So it just lets uric acid into kidney cells so that the enzymes in there can break down the uric acid. But if that protein's broken, then it can't get where it needs to get broken down, and then it just builds up. It builds up in their bloodstream. They'll get crystals in their blood. It's crazy. But it's a genetic disease, and because the population was so bottlenecked, they all have it, right? Because they all have this one ancestor that they all got it from. Well, they outcrossed the Dalmatian to a pointer, and they bred in a healthy version of that gene, a functional SLC2A9 gene. Well, it took 30 years for the AKC to say, okay, after backcrossing generation after generation after generation, they were like, okay, these are real Dalmatians. We'll let you breed them with other Dalmatians. But a lot of people still don't accept it. That's one place genetic engineering could help you out. But when a whole population is sort of infected with a genetic disease, you can't breed it out. We just won't breed the bad ones because they're all bad. So genetic diversity means you've got knobs you can turn, right? Like if 10% of the population had hyperuricemia, you could say, okay, well, we'll just select against it and it's gone.
Right.
Easy. That's something dog breeders know how to do, but it only works if you have genetic diversity in the first place.
Right.
So, okay, my Google Home is listening to me and talking to me now.
She said she want to listen to C.D.C.
Thank
you, Google.
So having genetic diversity gives you control. It gives you the ability to make adjustments. Right. The downside of genetic diversity is it can lead to things that you don't want. But I always look at it as it's about order and disorder, right? And as a breeder, that's a big concept you have to really get your head around, is that a certain amount of order is necessary, right? Because if it's complete disorder, you don't have anything. You don't have a breed. You don't have a line. You have nothing. So you need them to be organized in a way that you want them to be organized, right? This is what the breed is like. This is what the line is like. And then you need a certain amount of chaos. You need a certain amount of disorder. Because if it's 100% orderly, then if every dog is identical to every other dog, you will never have a dog who's unexpectedly great.
Right.
You will never have a dog born that just blows them all away and resets the standard for greatness. Because you need disorder. You need that to come about by accident. You need that to just emerge from the system. And so you need a certain amount of disorder. Now, for every unexpected greatness, you'll have unexpected disappointments too. Right. And that's part of it. So certain amount of orderliness means that most of the time you get what you want, but sometimes you get a little something different. And that can be good or it can be bad. And so balancing those two forces depends a lot on what you want, how close you are to getting what you want, and how much change you need. So if you're in the early part of your program, you need a lot of change, right? Because you're not where you want to be. You're just starting. You got a lot of changes to make to your line before you get there. So you want a lot of diversity, tons of different genes all in the pool, and you can just pick and choose, and you can make changes fast. Right. So in 5 generations with this hugely diverse genetic population, you can just turn all the knobs you want, and you have all the things to change. You know, every litter, you've got dogs that are so different from each other that you can go a lot of different directions and make big steps.
Right.
But when you get there and you get where you're going, you want to slow all that down. And so you slow it down and you do more and more line breeding and less outcrossing, so that what you get is more and more consistent over time. And all the steps are smaller and more thoughtful and more close, because you're taking the big leaps and then you're just honing in on that exact target with small steps.
Right.
So in that case, outcrossing can become bad. Like right now, I'm loath to outcross my line because it's so close to what I want it to be.
Right.
That if I were to throw in like a Corso, it's going to throw me really far towards Corso.
It's just opening up a whole nother door for different things that might come with that Corso.
Totally. And so the dogs will be half Corso, half Midgard, but I want them to be 99.99% Midgard. A little bit of Corso maybe is what I wanted out of that dog. And so how do I get a little? So I've got to take generations to breed it back to only get a little of that dog.
Right.
And so
more time, more money. It's a lot that comes with that. Yeah,
it is. And so sometimes what I'll do is I'll do outcrosses in advance of the outcross that I really want to do. So I'll breed a dog that will balance a dog that I want to outcross to, that's already a Midgard. And then I'll take that dog, the offspring of that, and I may do it again with a different Midgard, and then take the offspring of that and breed that into my line. And so that dog now gives me a little bit of the other dog that I wanted without throwing me too far. So sometimes you have to build separate lines just to breed into your line so that they don't throw your line off. But you can't just line breed all the time unless you just have a ton of money and your line is massive and you have 400 dogs on your facility.
Right. Yeah.
But if you can, so outcrossing is a tool that helps you make changes. And it's good to have a little bit of disorder in the system all the time because it gives you flexibility. But it's also something that you have to ratchet back on as you get closer and closer to your goal. But every now and then you may find yourself bred into a corner, and that's something that you have to be aware of. And if you're a smart breeder, you'll avoid that most of the time. You'll kind of see where you're going. And I've seen a lot of people that are like, I want to do this 3-way cross. I'm going to breed this to this, and then I'm going to cross that to that. And then that'll create my line. It's like, okay, what are you going to breed that dog to?
Right.
And a lot of people are like, oh, I didn't consider that next generation.
Yeah.
It's like that dog is the dog that you really want. You need something to breed it to, or it's a dead end. Yeah. So you got to be, okay, well, then I'm going to do a parallel line and then breed them together, or I'm going to do this, or I'm going to do that. So it's something you really got to plan through and think through. And you also just have to kind of be open to opportunities. Like there will never be a day where my stud book is closed, right? There will never be a day where I will say no dog in the world is great enough that I might breed him. Because if you showed up, you brought a dog to my yard and it was the best dog I'd ever seen, I'd be a fool to turn you away, right?
Right.
And I'm just not going to be a fool for just because I decided my stud book was closed. No, if you bring greatness to my door, I want it.
Right. Yeah, I mean that's a good way to look at it. I mean, why not? Why not take the chance on that great dog? Yeah. See, I was gonna ask you another question. I mean, that's a whole nother show in itself. I was gonna say, are dogs mutts? I mean, are all dogs mutts? I was gonna ask you about that. We're gonna save that. We're gonna save that one.
Okay.
Okay. Let me see. So, this is a real good question, I think. So it's on subject, but kind of off a little bit. But so you have a little bit of game dog blood in your dogs. So, what is your take on gameness? Where does it derive from? Is it natural? Well, of course it's natural. Excuse me. But I mean, what you don't see it in a lot of animals. So, where does it come from?
Yeah, so gameness is complicated and terribly misunderstood. I think Lee Robinson has a lot of great takes on gameness. He's probably thought about what gameness is derived from in a meaningful and insightful way more than probably anybody, myself included.
Yeah.
But my personal perspective on gameness, because I don't believe that gameness, while it might have emerged from nature, I don't think it's natural in the same way that prey drive is natural.
Right.
And I've heard a lot of people say that. I mean, the argument is gameness as a concept refers to this idea that's mostly found in game type pit bulls, right? Of a dog who's just willing to die fighting, basically.
Because how many animals are like that where they want to die? I'll die. We finna get down. You see the biggest predators, the top predators in the world. Some lions will fight to the death, but some don't want to get injured or don't want to die, so they can't hunt or live.
Yeah, and that's natural selection. Obviously, if you were a hyper aggressive lion that just wanted to kill everything, no matter what, and were willing to die, for the chance to do it, you're not gonna live. You're not gonna make it. So my particular my breakdown of gameness is that they're basically adrenaline junkies. And so what has happened is any animal in a fight gets an adrenaline rush, even humans. I mean, anybody who's been in a fight knows there's a big rush. And honestly,
in the mouth, you got adrenaline. Yeah.
And so I did martial arts for a long time, and I got hit by a lot of people, and it's fun to fight, right? So when you get punched, it doesn't feel good, but the adrenaline and the rush and the challenge and the sport of it all is exciting, right?
Right.
And some people are willing to do incredibly dangerous things for that kind of excitement, right?
Yeah.
Jump off a perfectly good mountain in a squirrel suit and maybe hit a rock and die. Maybe you make it to the ground. And people do extreme sports all the time for that adrenaline rush. And that's what I think is really going on, is I think these dogs are naturally adrenaline junkies, and they get an extreme adrenaline rush from any kind of conflict. So I think they have the dial for fight or flight is cranked really high, and the flight response is cranked really low. So that just means fight is really high, and the adrenaline rush is so extreme that they just, like, their mind is just exploding with excitement. It's just way over cranked to the point that normal signals like pain and survival and stuff are just not nearly strong enough to actually motivate any kind of change in behavior.
Right.
And so I think that's really what's happening. And I think it's so fundamentally unnatural to happen. Like there's so many systems that are not supposed to let you do that have to be like turned down while other things are turned up, that it's that's why people don't get it, right? Like that's why it's so,
because our brains are set up to like survive, live,
stay alive.
Yeah,
totally. And also, and it's not just that that's why people don't understand it, but also that's why it's rare.
Right.
Because like the particular genetic combination that would make that happen is odd. It's strange, right? It's something that there's a lot of changes that had to be made to make an animal do something like that.
Yeah, definitely.
And so not all genetic changes are things that are readily heritable because of the way genes work. Like you can have traits that are polygenic, so they have a lot of genes involved. And then some genes are expressed in a certain way when they're when you have two copies, like one from both parents, and some when you have one copy from one parent. And so it may be that you got like 14 genes involved, and 3 have to be one copy and 2 have to be 2 copies and things like that. And nobody's ever done really dedicated scientific studies of gameness, because the only people who care about it mostly are dog fighters and protection workers.
Yeah. Yep. Or just working dog lovers, really. Yeah.
Yeah. And so there's no university of somewhere that's going to do a study of the concept, like the genetic basis of gameness.
Maybe we'll get somebody to do it with this interview. I mean,
if there was somebody who was interested in just the psychological phenomenon in dogs that's really rare and interesting, and also from the context of a protection worker, like a military dog or police dog or a home protection dog, you don't want a dog that's going to decide this is too dangerous, I'm going to run away.
Right.
You want a dog who can be in the worst scenario a dog can be in, actively dying, and is like, nope, my family's still going to make it out of this.
Yeah,
I'm going to keep going.
Right. Yeah, I mean, anybody watching, y'all, hey, but submit this video so we can get an understanding.
Good luck getting funding on your grant proposal, but we'll see what happens. Yeah. But hey, you could probably get the Defense Department. They might want it in their super soldiers.
Maybe, yeah.
Genetically enhanced super soldiers might need some gameness.
Captain America.
Yeah.
Okay, so let me see. So I had this question from Jalik the student or Jaguar the band dog. I'm not sure if you know him, but he's been doing interviews for a minute. Shout out to that brother. Says, what does the process of selection look like for you when, say, for example, you're looking for a dog out of a breeding to use in the future as maybe a dog your program, a hog hunter wants it, or a protection trainer wants the dog?
So I do a series of tests. So a lot of people do puppy testing in a lot of different ways. There's a fistful of things that I'm looking for. The main thing I'm looking for is how they process stress and their drives. Yeah. So the two big things that I see people make mistakes on is, one, they don't do the tests repeatedly and they don't do them consistently. So good science is about good data, right? And I try to take a scientific approach to this. So if you are testing your puppies, what I'll see a lot of people do is they'll do some either nonsense test that doesn't really tell you anything other than maybe like, this dog has good prey drive. And that's great. That's way better than doing nothing. I've seen so many breeders who just pick one because they're like, I got a good feeling about that one. And it's like, okay, but why? And so, and some people do. They totally get by on just gut and intuition, and it works out for them, right? But that's just not what works out for me. So for me, what I do is I do testing. So I'll test a few different things. One, I'll test all their drives. So I test a prey drive just with sort of your typical stuff, toys and flirt poles and things like that. One thing I've noticed about testing for prey drive specifically is that you need to test them individually and collectively, because some dogs have a lot of prey drive around their litter mates for two reasons. One, it's competitive, right? They want it because they want to take it away from the other puppy. And you need to know the difference, because you get that dog out there working on his own and maybe he doesn't really care.
See,
right?
let me, not to cut you off. I had a hog hunter on, Dean Ross. I'm not sure if you know him, but shout out to him. But he said the same thing. He said he tests a dog by itself. He said that dog, if you get that dog by itself, he may not want nothing to do with that hog. Say he might get the hog might hit him and then he engage, but sometimes the dog doesn't want to engage unless there's others with them. So he separates that dog with just the dog and the hog.
Yeah, same. And so you want to test their you want to test them together and individually for prey drive. And there's a couple of things you're looking for with prey drive. You're looking for not just the intensity of their prey drive. That's kind of where everybody goes. But you're looking for two things. You're looking at the threshold of their prey drive, and you're looking at the intensity of their drive. So one is, how strong is the drive? How motivated are they by this internal force? And the second one is, how easy is it to stimulate? So that's the threshold. So some dogs will have an incredibly strong prey drive, but it's got to almost look like a injured rabbit for them to actually care, right?
Right. Yeah. Okay.
But once they do care and they identify that thing as prey, it's on. They're crazy, right? But sometimes a dog will just be like, oh, that leaf twitched a little bit, I'm on, you know? But that dog may burn out quickly and may go, oh, I played with it for a minute, I'm done.
Right.
So the threshold, and usually they're linked, but not always, right? So you want a dog who's got the right threshold, which for you might be higher, might be lower. It depends on exactly how you want your dogs to work. And then the intensity of the drive might be higher, might be lower. It depends on how you want your dogs to work. So you got to look at both. How easy is this puppy to stimulate? And then how responsive is that puppy after being stimulated? And so both of those are going to come in prey drive. And you also need to see, is this real prey drive that's like an internal force coming from this dog's desire to hunt and catch and tug and all these things? Or is this competitive prey drive where you're just trying to take it away from his siblings just to prove to them that he's bigger and badder than them?
Right.
And that's important. And then you do things like you test their defense. And that needs to be done very carefully, because you want to see that they have a defensive reaction, that they can recognize a threat. Because you don't want your working dog, well, again, this depends on how you want your dog to work. Right. For me, I don't want my dog to be like a Labrador, right? That just everybody's your buddy.
Right.
So
just
yeah. So I want them to have a sense of danger in the world. Now, I don't necessarily need every puppy to just charge forward and try to take out a guy, because puppies shouldn't, right? Puppies are protected by the pack, and when they grow up, they protect the pack. And that's normal behavior for a puppy. So a puppy that stands his ground or moves forward is great. But a puppy that backs up a little bit but recognizes a threat, I'm not against it, as long as they don't just flee, right? If a puppy just turns tail and runs, I'm like, okay, he might not have the confidence I'm looking for, but he does have the drive.
Yeah.
A puppy that just has no idea anything's going on, and I usually do this with like distant agitation, and I'll usually have an adult nearby to bark and react aggressively, so that the puppies cue in that much easier and recognize the thing. And then I'll take the adult away and do it later and see if they still recognize the idea. Because a lot of times when you're talking, because I'm talking 5-week-old puppies, right? Like they're clueless about anything in the world most of the time.
Right. Like they're babies, basically. Yeah.
And so it helps give them a little hint early on. But with Mastiffs, defense is not hard, right? Mine are heavy Mastiffs, so I basically never have a dog without some kind of defense. Right. But if you were breeding like a lot more pit bull or something like that, you may want to test this more thoroughly.
Yeah.
So for me, prey drive is something I had to test more thoroughly, because again, I'm mostly running a lot of Mastiff blood. But the genes are kind of on my side here. So For defense, I'm looking for their confidence and I'm looking for their ability to alert. So I'm testing, again, that threshold for defense, like how much stimulus does it take for you to realize there's a threat? And then how far is that going to take you? Like how strong is that reaction? And basically what you're talking about is you're triggering their fight or flight response. And you want to see how strong that response is, like how much adrenaline's hitting their system and how much of it they can handle and move forward. But again, you got to realize these are puppies. You can't start putting pressure on them like you're agitating a grown dog. You will make them afraid. So you have to be smart. And you don't want to traumatize your puppies before they are even 8 weeks old. But the next thing you do is you start looking at how they handle stress and how they handle so you're looking at their confidence in the world around stimulus, and loud noises are great for that. Either gunfire or just clanging some pots together and stuff like that. But there's two things. You're looking for their general confidence, which is like, I'm experiencing a new sensation that's maybe a little overwhelming. How strong does that have to be before I start looking for a way out, right? And if you've got a really confident dog, they're gonna be like bang, bang, bang. They're gonna be like, what's going on over there? And it's not gonna be a big stressor. So you got this how hard are you to put into a stressed state is your confidence, right? Nerves is once you're stressed, what has to happen for your stress levels to fall? So everybody's seen those dogs that are like, it's thunder outside or something, and the dog's freaking out.
Yeah.
Or there's fireworks and the dog's scared to death, even though the fireworks are forever away. And even if the fireworks show goes on for an hour, the dog's still stressed after an hour.
Right.
And some dogs are just asleep. And some dogs will be maybe nervous about it at first, but then they're like, oh, okay, nothing's happening to me. I'm not actually in any danger. I'm just going to relax. And so a dog that has bad nerves will get more stressed over time. Like repeated exposure to that stressor will make them more and more and more stressed. And that's just a mess that never gets better. And it's genetic. And people don't accept that it's genetic, but it totally is. And you've got to select hard against that shit because there's no working dog that does better with that. So, and you can train the shit out of them and make them better, but you don't want to have to do that. You're the breeder, breed better, and you don't have to worry about it ever again.
Yeah.
But what you want is you want a dog who's like, oh, I'm stressed. But repeated exposure to that stressor makes them not care anymore.
Right.
And that's what you want. So you're like, oh, bang. Oh, man, that was scary. And then the next bang is like, oh, and then it's bang, and they just ignore it.
Nothing happened. Yeah.
And so it's what you want. You want a dog who is hard to stress. And when they do get stressed, they process it well. So that's nerves and confidence. And you can also do other things. So do multiple tests for nerves and confidence, like put them on shaky ground, unstable footing, round surfaces, wobbly things. Like dogs that have poor footing and don't trust their feet or typically don't handle stress well. Dogs that don't trust loud noises, all these kind of things that are usually symptoms of bad nerve process or bad nerves or bad confidence. Expose them to that. Let's see how they do. And don't just do it once, because any puppy can have a good day. Any puppy can have a bad day. Right. I see so many people, they'll see a video of 10 puppies asleep, and they'll be like, that's the good one. And the others seem dumb. It's like if you saw Michael Jordan taking a nap at 7 years old, could you tell me what his basketball career was going to be like? Yeah. No, you couldn't. You don't know shit. You just get stuff up.
And man, so, a duck on your face. What you mean?
Yeah. I was like, come on, man. What are you talking about? Right. Don't be ridiculous. So what you need to do is you need to test them. So you test all your puppies 5 weeks, 6 weeks, 7 weeks, 8 weeks. You run the same test over and over and over again. And they're going to learn the test and they should get better. So day one, you test their prey drive. They don't maybe know what the rag is, whatever. By the 5th or 6th time you test them with the rag, they should be much better. If they're not much better, you don't want them. If they are getting better and better and better, then imagine 6 months from now. So they're going to learn the test, but the progress they make is part of the test, right? But so you're looking for not only consistent performers who pass your tests well and do it consistently, but who get better over time. Dogs that get worse over time or don't improve or have a good day the first day, but then they drop down and they're consistently bad, select against. If they have a bad day, day 1, 2, and then they do great and get better and better, keep them. Right. So it's about testing, looking for consistent performers who have growth potential.
Okay. I mean, we on the topic. I don't know how long I got you, so and I know
I
it's
got a
something
little
you
time.
definitely want to touch on. So Niall Cisa, how do you test for intelligence?
Oh, for me? Oh man. So intelligence is hard with a dog. There's a few different things. For one thing that really happens with, I disagree with how people grade intelligence in a dog, because what most people mean when they say a dog is intelligent is that they're trainable and biddable. So consistently, wolves are more intelligent than dogs, right?
Yeah,
But wolves are not very trainable and not very biddable. They
yeah,
just don't care what you want.
right.
And so that doesn't mean that they're dumb. But you can take a like a border collie and train the
Mm-hmm.
heck out of them. Does that mean that they're geniuses? It doesn't mean that they're dumb, for sure. I think consistently, like beagles are some of the dumbest dogs by breed. But beagles, I used to raise beagles.
Yeah, yeah, I remember you said that. Yeah.
Beagles are born with one thought in their mind. Like beagles from a working line are born
Mhm.
thinking rabbit, and they will never think anything but rabbit for the
Yeah,
rest of their lives. They're just born rabbit, 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 rabbit every day, every moment, every instant. And so you don't need a beagle to be smart. You need a
right.
beagle to be born obsessed with hunting
You just
rabbits.
needed to do his mission. Yeah.
Exactly.
You know, it's one thing I think about with the beagle. I'm like, I don't know. I don't know if I'm thinking of like the real small, shorter ones with a little bit of loose skin.
Yeah,
But
yeah.
I'm like, how does this thing catch a rabbit? Or how does this thing get a rabbit? Like it,
They
I don't
usually
get it.
they usually don't. Like you actually don't want your beagles to catch your rabbit.
Okay. Okay.
So usually what happens is with a rabbit, they'll run in circles, right?
Yeah.
So a pack of beagles will sniff out a rabbit and they'll jump the rabbit. And then they'll all bay and they'll bark and they'll find each other. And that rabbit will run. But rabbits are way faster than beagles.
Right.
And so, but rabbits will get tired. Beagles will not get tired. They'll run
Mm,
all day. I've
okay.
seen beagles chase a rabbit for 3 days. They will not stop. And so the rabbit will run a big circle trying to get back to his little rabbit hole so he can hide, right? And so what you do is you put yourself on that big circle with your shotgun, and
Yeah.
then you hear the beagles coming, and they're just like bark, 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 bark coming through, and then here comes the rabbit. And you've positioned yourself on like a lane or a clearing or something, and that rabbit runs right through, and you shoot the rabbit, and then here comes the beagles 10 seconds later chasing the rabbit, but you've already shot him and he's in your bag.
Right.
But if the rabbit gets pinned down in bad, so like a rabbit can run under briars and through all this sort of stuff, and beagle can too. They don't give a shit. They'll just plow right through thorns and
Yeah.
everything. But the rabbits, they they will get tired, and eventually the beagles will just run them down.
Mm,
And if your beagles are a little too fast, we actually had that problem. Our beagles got a little too tall because they weren't really beagles. They were beagles with some. They were beagles with some others. Some of ours had blue
yeah.
tick in them and other things, you know. So I mean, they were beagly. They were like good old boy beagles, but I hadn't seen registry papers in many generations. But the beagles got a little tall and they were a little fast, and so they
Yeah.
could just push the rabbits harder. And so the rabbits started getting caught. And so it's like, okay, we got to breed them shorter because they're getting too fast. And so breed them back shorter, and it slows them down, and that gives the rabbit more of a breather, allows you to get in position faster, and then they don't catch.
Okay.
Yeah.
I didn't mean to get you off
No,
subject of the question. No, neither. I didn't mean to do that. My bad, Niles. Okay. So let me see. We're gonna get back. I mean, we kind of started in the sciencey side. So what is de-extinction, and what benefits will it bring, and what problems may occur with that?
So Deextinction. So Colossal is a company out of Dallas, right? So
Yeah.
they're kind of our only competition in the sort of animal genetic engineering custom animal space, which is neat. And I actually like a lot about Colossal. Like I think they've set themselves a really hard mission. De-extinction is fundamentally difficult. Like if your job is I want to make unicorns, that's actually a lot easier than I want to bring back a woolly mammoth. Uh, because they're trying to make something that has existed before and has a specific definition, and that's why everybody's kind of going back and forth right now as to whether they obviously recently released their thing about making direwolves, right?
Yeah.
And bringing them back from extinction. And so it comes down to what your what you mean, right? So a lot of people are saying, well, they're not really direwolves. And in one sense, it's true, right? They're not really direwolves. So direwolves branched off from wolves about 5 million years ago. Yeah. And they're so different that they're actually, direwolves are more closely related to jackals than they are to gray wolves.
I know, right? You had a lot of people just now say, what?
Yeah. So direwolves.
I said the same thing this morning. Somebody was like, what? Really? I was like, yeah.
Yeah. So direwolves are this ancient lineage. So gray wolves and coyotes and all these actually emerged in Asia and Europe, right? And so there were canines all over the old world, right? Yeah. I mean, you got painted dogs, you got jackals, you got golden jackals, you got gray wolves, you got all these different animals. And so in the Americas, there was another lineage that moved across like millions of years ago and became the direwolf, right? And this is North American lineage. And there were actually several different species and groups, and then various ones died off. And then the land in Asia and in North America got reconnected. And then something like that. Kind of, yeah. It was just various ice ages, and so the ice will reform and then it'll go away for a while, then it'll form again for a while. And so gray wolves come across, right? And the gray wolves are now living in North America with the dire wolves. And the dire wolves actually lived in the south and the gray wolves lived in the north. Okay. So the dire wolves lived in like California, Texas, Mexico, all through what we think of now as like coyote territory. Right. And the gray wolves lived up further north in Canada and places like that.
Colder, yeah.
Yeah. And so they didn't really cross ranges a ton. There was obviously some places where they crossed ranges in southern Canada and northern United States.
Right.
But and they coexisted for a long time. And then humans came over. And interestingly, some of the very, 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 very first humans who came over, Native Americans to the United States, had some dire wolves. We found some dire wolf skeletons that were showing signs of domestication. So they might have been breeding dire wolves, Native Americans.
What? That's crazy.
I know.
That's crazy.
Yeah. But then they went extinct, right? Mm-hmm. And so they were only left with the coyotes, the red wolves, and the dire wolves.
What was the cause of extinction, if you know?
There's people say human activity, climate change. Obviously, the Ice Age ended, so that changed a lot of things. But probably a combination of the Ice Age ending, competition from gray wolves, habitat destruction from some of their prey items going away, and they had it harder in some ways because the gray wolves hunted smaller game, deer and things like that they still hunt, right? And the dire wolves were specializing in things like buffalo.
Yeah.
And buffalo were some of the smaller things that they hunted. So during the Ice Age in North America, there were all kinds of giant animals.
Megafauna. Yeah,
exactly. And so there were all giant ground sloths and all sorts of crazy things, terror birds, just weird, crazy animals that are all extinct now. And so probably a lot of that was a lot of their diet. There was like woolly rhinos and all sorts of crazy things in the Ice Age. But like they had big packs. They had crazy injuries. So like the number one place I think in the world for direwolf skeletons is the La Brea tar pits in California. Because it'll be the ratio of like every herbivore is something like 30-ish dire wolves to every herbivore they've found. So it's like, so they're like, a bison will wander off into the tar pit and get stuck. And then a pack of 30 dire wolves will come along and try to eat it and also get stuck.
Right.
And so unfortunately, tar pits destroy DNA. So none of those thousands of skulls and skeletons give us actually DNA.
Right.
And for years, I thought we would find direwolf DNA probably in the Andes because it's one of the places that's still cold that was within their range because most of their range is sort of hot places, and that it's not good for DNA. But as long as it's good and dry, that can also work. But like the tar pits were way too hot. I mean, it just cooked everything.
Right. Yeah.
But the dire wolves clearly moved in big packs. they had huge injuries where like parts of their skulls are crushed, bones broken all over the place. So the things that they were hunting, and they were much more robust. Like they weren't as big as like Game of Thrones direwolves, right?
Right.
They were the mastiffs of the wolves, where the
Yeah.
Grey Wolves are more like the Great Danes of the wolves.
I seen some. I don't know. It said it was like 3 feet at the withers or something like that. It was somewhere. It was a measurement I saw. I'm not sure if that was accurate.
Yeah, something like that. So I mean, like gray wolves are tall. People don't know how skinny wolves really are.
Yeah.
Like your typical wolf, if you went to like you saw a wolf in Wyoming or something like that, it's probably going to be about 80 pounds. But they look bigger because they have big
Yeah.
heads and they have a lot of fluff.
Yeah.
But they're leaner and lankier than they look like they are.
Right.
So like if you get one, just shaved him down, he'd look like a Great Dane. But they're tall. Wolves are tall. And some of the biggest wolves, like big gray wolves, can run like 130 pounds, but they'll be Great Dane height. I mean, they're tall.
Yeah.
But dire wolves were a little taller, but mostly thicker. So they had heavier bones and just more muscle on them, and bigger skulls and broader. So clearly they were doing more fighting and less chasing, right?
Yeah.
Because I mean, wolves are pursuit hunters. They're not like tigers. They're not just going to go in and just kick something's butt and kill it. They just run it to exhaustion and then eat it. They just take turns chasing this one deer for miles and miles and miles. The pack taking turns chasing this deer until the deer just drops dead of exhaustion and they eat it. So that's how wolves hunt. Well, clearly the dire wolves were hunting things that fight back more, and they took a lot more damage because their bones are shattered and broken in terrible ways, and they've healed from it. So clearly they're also caring for each other. But the dire wolves, just fit this slightly different niche that apparently disappeared, and they did with it. But when there's no evidence that anybody has seen. Maybe Colossal has some new DNA evidence that they haven't released yet that shows gene flow between gray wolves and dire wolves where they bred together. So they're in different genuses. So it seems more like they just did not crossbreed or couldn't crossbreed. But if they do have some data on that, they haven't shared it with anybody.
Right.
So dire wolves were just this other branch of wolfdom. Really, they're giant jackals. They're more closely related to African painted dogs and jackals than they are to gray wolves.
Yeah.
But gray wolves are more, they look more like them. Like they look a lot like gray wolves. Their color probably was not the same. Most of the evidence points to them being sort of gray, reddy brown, more like a red wolf or like a coyote, or maybe even almost like a fox. But Colossal has claimed that they were really pale, which is weird. That doesn't match the current evidence, but maybe they have some new data that they haven't shared yet. But the mutation that they use to turn them white is a dog gene, not a direwolf gene.
Okay. Wow. I didn't even know that. Okay.
Yeah, because so like the mutation that turns Arctic wolves white is a different one because they're born brown and they turn white as they get older. But like a white dog is born white and just stays white. And so that's the mutation that they introduced to those gray wolves to make them white. But the whiteness is not really a direwolf trait. It's a dog trait. And I think they clearly did that because of Game of Thrones, right? They wanted that picture where they got a white direwolf puppy on the Iron Throne, and they got it. And it's awesome.
Wow.
So I think they did that because of Game of Thrones, which to me speaks to the fact that it's not really a de-extinction direwolf would be we're going to bring back this other kind of wolf. And from the perspective of an ecologist, if it serves the same function of a species, it's basically the same species, right? From the perspective of a biologist, species and where something falls in a taxonomy depends on its relatedness to its ancestors, and these do not have enough genes to be considered a direwolf. Like if you had a time machine and you grabbed a direwolf and you tried to breed it to one of their direwolves, it probably wouldn't have puppies. But if you bred it to any gray wolf you could find, it would definitely have puppies. So it's clearly a gray wolf, not a direwolf. But that's because if you're looking at it through the lens of a scientist talking about a species classification. If you are looking at it from a different angle, which is the one I actually prefer, which is that this is not a direwolf pulled out of the Ice Age. This is a direwolf pulled out of Game of Thrones. And if you're talking about a fantasy direwolf, so like Dungeons and Dragons, all kinds of like TV shows and movies, obviously Game of Thrones is the big one, have direwolves, right? Which are these big, like it's a big wolf, and often they're white and they're bigger and more robust and tougher and meaner. If that's what you mean when you say direwolf, then they're 100% direwolves, right? That's what they did, was they took wolves and they made a direwolf version of it. And I'm totally down with them calling them direwolves, even though direwolf has existed. Because are they direwolves in that they have the same species designation, like Canis dirus, or at least that's what they used to call it? But no. But are they direwolves in the same way? Like if I cross a golden retriever to a poodle, and if everybody can accept that I can call that a golden doodle, then I can accept that if you put a handful of direwolf mutations in a gray wolf and make it like a direwolf from Game of Thrones, then we can call it a direwolf.
I can see that. That makes sense to me.
Because it's like they made it, they get to name it. And if it doesn't have a name, they may as well call it direwolf, because that's really what it is. So it's really a fantasy direwolf made real, not really an ancient direwolf made real. So is it Deextinction? No. Is it awesome? Yes.
Right.
Yeah. Now I don't think they're going to be as big as like direwolves from Game of Thrones were, because they were like 500 pounds. I mean, I think Jon Snow had the thing up to like here, right?
That thing was big.
That thing was huge. But like I expect they'll probably get mastiff size, like 150 pounds, which is big for a wolf. Most gray wolves peak out at like 150. And these guys they say they're 20% bigger, which puts them on track to be about 130 for like a normal gray wolf, which puts them about 150. The biggest gray wolves on record ever, like 170. So that might so if they used those as the like beginning wolves that they modified and cloned, that's what they did. They took the wolves' cells and they modified them, and then they cloned from those cells. So that's how they got the wolves.
Wow.
So, and so they, so if those wolves were some of these giant gray wolves that you can sometimes, like Mackenzie Valley wolves run a little bigger, you can get wolves that are in the like 170 range. Those might even hit 200. Not going to be as big as like an Ovcharka or a big English Mastiff or anything like that, but be big for a wolf.
Yeah. Okay. What was I gonna say? I was just thinking about this. I was just thinking about it. So there's a lot of controversy with this newfound the direwolf. We're just gonna say that. There's a resurgence of the wolves in California. I actually got a buddy, I think I'm pretty sure he lives out there. I think, could be wrong. Shout out to Hunter Larson, but says that like they're killing livestock on farms and all that. So do you think there'll be some issues with this if it's released out into the wild?
I don't think they'll ever release direwolves into the wild. Okay. I don't think that's even the plan. Like they kind of talk like it is, but I think most of that is just because it's what gets them funding. Like they got $400 million from investors to do de-extinction work.
Dang.
So you got to talk a good game to get somebody to give you $400 million. Yeah,
you got to talk real good.
So their first thing they talked about for a long time was woolly mammoths, right? They're going to bring back woolly mammoths. And to do that, they were going to genetically modify an Asian elephant to make it woolly. And in the process, they made woolly mice as sort of a proof of concept. They did that. They released a paper about that last year. And so they made woolly mice. And so they probably could make a woolly elephant. The problem is there's like, as hard as this stuff is to do with dogs and wolves and stuff, it's like infinitely harder to do with elephants, right? Every step. Collecting an elephant egg, super hard. Like, how do you even do the surgery to get the egg into there, like collecting sperm from an elephant's got to be like a dangerous prospect. I mean, all this stuff is fundamentally more dangerous and expensive and just everything.
Most definitely.
So the mammoth will probably be the last thing they ever do. But wolves and some of these other species and stuff like that are just easier. And especially with dog cloning being relatively easy. So I actually am pretty sure the direwolves were dogs before their genes were changed.
Okay.
Not wolves. So what you would do, like the way that kind of cloning works is you take an egg cell, right? And then you stab it with a little needle and suck the nucleus out. And the nucleus contains all the DNA. And you suck out all its DNA. And then you take another cell, and you can do this in one of two ways. You can either suck its nucleus out and push it into the egg cell, in which case you've replaced all its DNA, except for mitochondria. But you've replaced all its nuclear DNA. Or you can take those two cells and you put them real close to each other and you give it a little zap of electricity and it just sort of merges the two cells like soap bubbles. And so you end up with an egg cell that's been merged with this other cell. It used to be like a skin cell, we'll say. And so what you can do is you can take a dog egg cell, suck out its nucleus, take a wolf skin cell that you genetically engineered, and then merge it so that the wolf skin cell's genome is now inside the egg and no other genes are. So that egg cell now has wolf genes. And so that's how you do it. Now, the other way with just injecting the thing. So the complicated part is the mitochondrial DNA, the DNA that you only get from your mother, is heavily involved in things like energy metabolism. And that's probably still dog. So you could probably DNA test these direwolves, and they'd still have dog mitochondrial DNA. So you could even tell who their mother was. But the wolf genes are only in the nucleus, and then the genetically modified parts are only a few very specifically modified sequences from the direwolf DNA, really on a file, like on a computer somewhere that they scanned when they did DNA sequencing of this old bone. And then they took that and they just altered specific spots to make it more direwolf-like, to mutate it in such a way. But the genes, so like if that wolf were to get loose, we'll say, because they got them in somewhere here in Texas, North Texas is what they were talking about. But they said they got layers of fences and security and drones and like the whole thing, right?
Yeah.
Because they're in so much trouble if this gets out and breeds in the wild. Like all over them. But like also they don't want anybody to steal their product, right? So they spend a lot of money making a direwolf,
right?
And I get it. Like that's one of the things I've been working on. I want to put a little bit of direwolf DNA in my dogs, right?
Yeah, you said that. You said in part one. Yeah,
I said that in part one a week before they announced this thing.
That was crazy. That's crazy to me, though. Yeah. I mean, man.
So I had no idea these were running around. This is just an obvious project,
right?
And so the dogs. My dogs could benefit. A working mastiff could benefit from some direwolf traits.
Yeah.
I think direwolves have the perfect skull for the kind of work that needs to get done. But there's also other things like we talked about with like longevity, size, things like that. There's some interesting traits that direwolves have. But they don't want somebody to come steal sperm from their direwolf and then just go breed their own direwolves, right? So a ton of security somewhere. So I doubt they'll ever get out. And they've got the money to make sure that it stays secure forever.
Yeah, that was my question. Do you think they will stay in captivity like the ligers?
Yeah, totally. That's what'll happen is they'll be effectively a zoo animal that you could go see maybe. It's kind of a Jurassic Park situation. They'll never be set loose. And I don't think it'll happen for any of the others either. Like maybe if they make a dodo or something, you know. But if they make a woolly mammoth or a Tasmanian tiger, I don't know that they'll ever turn them loose. Maybe in parts of New Zealand and Tasmania. But I think for the most part, these animals that are gone are going to stay gone unless it's something really recent. Like if we wipe out tigers and they made a tiger, we'd probably immediately reintroduce the tigers, right?
Yeah.
But we don't have to do anything fancy with tigers because we have tigers. We have tiger cells in a freezer. We can clone tigers, right?
Right.
So, and that's another thing that Colossal did that honestly doesn't get enough press is, even though they're my competition, they cloned 3 red wolves at the same time.
Wow.
And nobody's talking about it, but those red wolves are great because they're American. Like red wolves live in the Southeast in the United States. I've seen one in the wild, but there's only like 16 left in the wild.
I didn't even know that. Wow.
Yeah, they're super duper endangered. They're basically gone.
Yeah.
And there's a handful in some zoos around, but yeah, they cloned 3, which for a population under 20 is huge.
Yeah, definitely.
And they can do specific things. Like they could take a red wolf clone, and the problem with a bunch of clones is if you release a bunch of clones, you're increasing the numbers, but you're not increasing the genetic diversity.
Right.
Because they could take mutations that we know are in wolves and like other breeds of wolves and coyotes and things like that, and they could custom build in these mutations so that you can restore, or even genetic mutations that we find in red wolf, teeth or bones or dead red wolves, right? And so you could take one, or you could take like 5 clones, and you can make them a little different from each other, but in ways that are normal for red wolves to be different from each other. And then you make 5 individual different red wolves, and you can release them, and they're not all just clones of each other. So you're using the same technology. But, I think that's awesome. And that's something that hasn't really gotten any attention because obviously the direwolves get the big splashy headlines and they get to pose with George R.R. Martin, and it's the sexier headline for sure. Right. But the general technology is great, and that's the thing that I think is really interesting and useful, because everything they did with wolves you can do with dogs, and it'll all be easier. You could put those same direwolf genes in a dog. You could put basically whatever mutation. It's just money, and right now they've got the money. And as the technology gets cheaper and as it gets more accessible, they'll get less and less and less. And really, somebody only has to do it once, right? So, like, let's say I put some direwolf traits in a Midgard, right? And you got a Midgard from me or studied it out, and now your line also has some direwolf genes.
Yeah.
And then you could just breed and breed and breed, and now you don't have to do genetic engineering every time.
Yeah, that's amazing.
So a lot of these traits can be put in once and then just through normal breeding spread around. But as far as what the government will let you get away with, that may or may not be a lot. Because they're a lot more lenient than they used to be. I had a lot of fights with the FDA back in the day, but they were kind of freaking out about CRISPR early on because they were like, oh, man, people just do crazy stuff. And they've relaxed a lot in the last year, really. And honestly, I would be interested to find out if any of Colossal's money wound up in some politicians' hands. But but the rules around genetically modified animals have just gotten so much easier, much, like super quickly in the last little bit. And so I do think there's a good case for it, for genetic disease and stuff like that, but also just for custom animals, whether it's a dog or anything really. But I think the government will always get mad if you make like a new predator and release it into the wild. Yeah, EPA is going to come kick your door in and drag you into a little box somewhere, probably. But especially if they breed. But if you wanted to make a company that made genetically modified animals and sold them, and they were like fixed, and you had like reasonable biocontrol, I think we'll see it for sure soon.
Okay. See, man, we could sit here and talk about this for like 4 or 5 hours. I think this is a good question though. I know before, because I was really into like the extinct animals, woolly mammoth, saber-tooth, all that when I was younger. Still am a little bit, but I know there was a problem. Some people say the cause for extinction was the deficiency or the lower amounts of oxygen in the air. I'm pretty sure that's what it was. So with these larger animals, that we're trying to de-extinct or bring back? What problems do you think will come with the lower amount of oxygen in the air?
So to get to where that's a big issue, you got to reach all the way back to like the Carboniferous period, which is really far back, and we don't really have a lot of DNA from animals from back then. But it does speak to a couple of things. One, like a lot of these Ice Age animals, like the woolly mammoth and stuff like that, their habitat is like just near the Arctic Circle now, right? So like there's very little place for them to exist anymore. Like there's a reason elephants aren't hairy in Africa, right? So obviously they're not going to do well in a hot equatorial place if they got a bunch of fat on them. So, the environment you're talking about is like Siberia and stuff like that. And these mammoths just don't have an environment, and oxygen and stuff like that. Oxygen levels have fluctuated throughout history. And it used to be significantly higher. Like back in the Carboniferous period, it was like oxygen levels are like 19-20% right now. I think it was like 35 plus. And that's when you see like the giant dragonflies and things like that. These huge super bugs. But bugs just can't get that big. And no amount of well, that's not true. The amount of genetic engineering required to make a bug that could be that big is greater than just making it like it used to be. Right. So bugs can't get that big because they don't have lungs generally. And they don't really have like a centralized circulatory system. They breathe through sort of holes in their sides. And there's like spiders that book lungs and all this sort of stuff, but it's not the same. And that creates limits to how well they can breathe and pump oxygen around their bodies. So it's easier to do that when you're tiny. So bugs just don't get past this big. So to make a bug my size, I'm going to have to do a lot more than just crank up his growth hormones, right? Yeah. Or even make it like it used to be, because it used to live in a different world. And so to make a bug that big who lives in this world, I'm going to have to make something that's never been. So I'd have to make a bug that had heart and lungs kind of like we do that could get our size. And I'd probably have to make its exoskeleton a little bit different, because it's going to be too heavy and it's not going to be able to hold its own body when it molts and all these other things. So you're going to have to make some really significant changes to the way a lot of these ancient animals work so that they can work in today's world. And that's okay, I think, because even if you want to make something that existed in the past, which honestly I think is kind of boring compared to making something that's never been. Like, what's a cooler world? A world with woolly mammoths in it, or a world with dragons in it?
Yeah, I don't know if I want to be here with no dragons.
Let's say little
how to train your dragon though.
Let's say little dragons. They get about the size of like a bull terrier, right? Yeah. So they got the brain of a cat. It just follows you around. It eats mice. Just looks like a dragon, right?
Right. That'd be cool.
That'd be cool. Who wouldn't want a pet dragon, right?
I mean, come on.
Like if your neighbor had a pet dragon and you didn't have a pet dragon, you spend a lot of time at your neighbor's house. Right?
And if he don't let me over, I'm hating on him.
Exactly. Right? Yeah. And so, even people that are like super against GMOs and genetic engineering and stuff that I've talked to, you say, okay, but if I could use genetic engineering to make a pet dragon, would you want one? They say, okay, we could do that, but that's the only thing we could do. And so, because people don't want to live in a world that doesn't have pet dragons, right? Or like if you can make a unicorn. And the thing is, you can make, people they don't spend a lot of time thinking about creature design, like designing animals, because for so long, there's just not a lot you can do. But really, that's what dog breeders are, especially like band dog breeders and breeders of crossbred dogs. I mean, you're an organism designer. That's what you're trying to do, is make an organism that you want. And you're limiting yourself to just the genes available in the dog, right? Or at least just available in the canine. You could use some wolf blood. But the dog and canine blood that you're using is so diverse, right? It's like you got Chihuahuas and you got wire-haired dogs and you got fluffy dogs and bald dogs and just everything. Yeah. You can make like a dog with a you could cross a Great Dane and a Chinese crested, and you could get like a hairless dog with just like a little poof, but he's the size of a Great Dane, and he's got no tail and corgi legs, right?
Yeah.
I mean, you could mix all sorts of traits together and make
Right.
the craziest dog you can dream of. And so you could design a lot of different dogs that have never been. And that's something dog breeders do. And so dog breeders are kind of the only people who are out there designing organisms and have been for a long time. And so now the technology has opened up a lot more possibilities. So like if you want to make, like say you wanted to make a unicorn, right? What would have to happen to turn a horse into a unicorn?
A lot. I couldn't even tell you, but
right. And I mean, not just on the genetic side, but like on the trait side, like what traits would a horse have to not feel like a horse with a horn?
Right.
And so you walk up to a horse who's got a horn growing out of his head, you'd say, holy shit, that's a unicorn, right? But a little bit of the back of your mind would be like, y'all just put a horse on a horn, or y'all just put a horn on a horse.
Yeah.
But if that horse smelled like apples and was immune to all horse diseases and had the iridescent cells of a salamander, so that when the sunlight hit it, it had a little bit of rainbow shimmer in its skin.
Wow. Yeah.
And then let's say you tied the bioluminescent genes from a firefly into its oxytocin receptors, so that whenever it felt bond, whenever it felt loved and cared for and close and emotionally connected and stuff like that, it started to gently glow.
That'd be, man.
You wouldn't feel like this is a horse.
No,
you'd be like, okay, y'all made a real unicorn.
Yeah.
And it may have some horse ancestors, but this
your daughter not gonna be talking about no pony.
Yeah, exactly. Yeah. And so like the things that you can do, taking traits from different animals and putting them together in like a thoughtful way where you can make it something that never was, is the space of animals that have never been yet is so much larger than the space of animals that used to be, that the amount of creativity you have to make things that never were is enormous.
Yeah.
And we're going to make all kinds of crazy shit. and I do think we're going to find ourselves in the future in an environment where almost everything is man-made. Whether that's 1,000 years from now or 1,000,000 years from now, whatever it is.
I mean, see that.
You know, it would be like, oh yeah, you know, these trees are genetically engineered, these animals are genetically engineered. Mosquitoes don't bite humans because we engineered that out.
Right.
You know, they don't carry malaria because we got rid of that. We didn't like it. You know, oh, and these you know, these pecan trees produce pecans that are this big because we wanted it. You know, just whatever. You know. And I think
I can't imagine how many times you've heard "stop trying to be God" or those type of things. I can't imagine.
I think we'll always have that that idea of like somebody's playing God.
Yeah.
But I think we would not be who we were if that wasn't the plan. You know.
Yeah.
I think we wouldn't be as smart and resourceful as we are if making changes to organisms around us isn't what we're supposed to be doing.
Okay.
You know, I think just look at what we've done with agriculture. You know, we've made plants, like you look at wild plants, like things people don't know is like broccoli, cauliflower, basically all the lettuces, cabbage, Brussels sprouts, a ton of these plants that we think of as different plants are all one plant. We just bred them for different things. So it's like we bred wild mustard into a dozen different plants. And then we took those plants and we made them like half the things that we eat. And so we've created all this new food for ourselves out of just breeding, just generations and generations, thousands of years of farmers working their asses off to make their plants better.
Yeah.
One generation at a time, slow and steady. And we've done amazing things. And then when genetic engineering came along, we were able to do it even better. And so the process that we have of improving our dogs, like we've made dogs into what they are. Like without modifying organisms, we wouldn't have dogs. We'd just have wolves.
Yeah.
And we wouldn't trust them around our kids, right?
Right.
So we've made dogs better and we've made them worse because we've done some good things and we've done some bad things with this power that we have. And we've made some of our plants better and we've made some of them worse because of this power that we have. And we'll do the same thing with things in the future. So I think we'll make a lot of things, a lot of different organisms better, and we'll make a lot of them worse because we're just not perfect. But I do think in the end, it's part of being human to change the living things around you because it's something we've done forever. Sure. And it started with dogs.
Yeah. And that what I just said, playing God, I mean, that's even said in dog breeding. I mean, with the cross breeding and like the bull herders coming on the scene, and I mean, it's everywhere. So it's going to be said. It's going to be a split, I think, also.
Yeah, I think it'll always be. People will always be back and forth on that one. And I think it just depends on whether you think it's something we should be doing or not.
Yeah. After this, I'm gonna let you go because it is. I mean, I know we've been on here for a minute. I think this was a great episode, though. We made another banger.
Nice.
Talk about the GMO tomatoes that you planted.
Oh yeah. So I mean, I've got some some genetically modified tomatoes that I'm just growing in my yard, just as tomatoes. You can buy them. The ones I have are I have a couple of different varieties, but one of them is this sort of purple tomato. That just has more anthocyanin, which is a chemical that's in plants, like blueberries and blackberries and things like that. And it's an antioxidant. So think of it as like an anti-cancer chemical that happens in plants. And that's one of the reasons why they're like, oh, you should drink red wine because it's got antioxidants, and anything with like grapes. And that's why they tell you to eat plants with color on them, so eat some like red plants, some purple plants and things like that because they're good for you. Well, that's what they're talking about is these phytochemicals, right? So plant chemicals, basically. The anthocyanins are one of them, and they make things purple and blue and black. So a lot of times when you see those kind of plants, that's what you're talking about is anthocyanin. Well, they took anthocyanin not from a plant, but actually from a snapdragon, which is a flower. But it also makes anthocyanins. It just makes a ton of it. So it's a really good gene. And so the anthocyanin gene from snapdragons, the flower, was put in the tomato. And so these tomatoes just make a bunch of anthocyanin. And there are tomatoes that naturally make more anthocyanin than others, right? And so you can just buy those, but they also can just make them. And you see, like, sometimes you see purple potatoes. It's the same kind of thing.
Yeah.
But those aren't genetically engineered. But yeah, so I mean, I've just been growing them in my yard and, making tomato sauce out of them and stuff. So, I mean, I think it's an interesting thing, but I'm trying to cross a couple of different varieties just to get that gene into it. Cause they're these little kind of sauce tomatoes. And I really want like a better boy, like big ones. I like a big, cause I'm a tomato sandwich guy. Like,
okay. Yeah, I don't like tomatoes, but
yeah, I do. So I'm from Mississippi. I ate a lot of tomatoes growing up.
Yeah, I know they do that down south. They put salt and pepper on them, just eat them. Yeah,
so good. Especially, I got to brag about Mississippi a little bit. Well, Mississippi, we have the perfect climate, right? You can grow 3 tomato plants and make more tomatoes than you can stand. Like, I mean, your whole table will be full of tomatoes every week, and you could just be eating them constantly, and you'll never get enough, and you'll freeze them, and it'll last you for years from 3 plants. Because it rains every week, it's warm, it doesn't get super hot like it does in Texas, it's never dry, the climate's just super good for agriculture, right? And so Mississippi is just busting out with just green everywhere. It's really beautiful. So you plant a little garden, little 10 by 10 patch of peppers and tomatoes and all that stuff. And I mean, you have more food than you can dream of. And so here in Texas, it's been a struggle. It's dry, it's hot, it's a struggle. But I'm adapting and I'm learning how to grow things here. But because my tomatoes do not do as good here, I overwintered them in a little greenhouse on my porch. And so these are actually, I've got tomato yield right now. I had tomatoes in March which is great. And so because it's so hot, it's also the winters are pretty mild, so it's pretty easy to overwinter stuff. So that's nice. But you just basically can't grow anything in summer. It's just so hot and so dry. But the tomatoes themselves, I want to cross the variety into like a big Better Boy tomato, because that's what I grew up on. You just take your big fat tomato slice, a couple of pieces of bread, some mayonnaise, sandwich, you're done. Oh, it's so good, and especially when it's a really juicy tomato and you get it about that thick and it's crisp. Oh, it's so good. But I want to do that with these anthocyanin tomatoes because they actually have a lot of really a lot of flavor. And some of that's because they're coming out of these little sauce tomatoes, which are really bred for flavor, not size. But the anthocyanin also upregulates these phytochemicals production, which do have a flavor, right? So it's a flavorful tomato. And so I want to cross them with some other tomato varieties and get like a super tomato. But, that's not too interesting, really, unfortunately.
No, it is. I mean, it is, though. I mean, like, it really did. It catches my eye, like everything else we went over.
Yeah, and I think it's just something that will become more common. Like, people don't generally grow a lot of GMO tomatoes and stuff. But I'll tell you, I've got another plant in my house that I think you would find more interesting. Is I've got glowing petunias.
Wow.
So they actually put bioluminescence genes in a plant.
Yeah. Wow.
And these are fungal bioluminescence. So there's some mushrooms that glow.
Yeah.
In the dark, they produce light. And they took those genes out and they put them in petunias. Just little flowering petunias, and you can look them up, and you can buy them, and they'll ship them to your house, and you just grow them in a little thing, and it's amazing. I mean, you just put them by your bedside, middle of the night, you wake up or whatever, you look over, and it's just glowing flowers. I mean, the whole plant glows. Leaves glow, the stems glow, the flowers glow. The flowers themselves glow really bright, and then the stems are pretty bright, and the roots are really bright. The leaves are not quite as bright, but I mean, it's crazy. What I want to do is get like a bunch of them and plant them down my driveway.
Yeah.
So then it's just like this row of glowing flowers down the driveway.
When you do that, send me a picture.
Oh yeah.
Send me a picture.
And the bioluminescent, and you can look up pictures of these bioluminescent flowers, but they're genetically modified flowers to glow. And like one of the things I also want to do is pull the genes out of the petunias and put them in some of my Palo Verdes, which are these green sort of desert trees that grow really well here in Texas, so I can have glowing trees.
Okay. Man, you yeah, we gotta what y'all think? We gotta have Mr. Ishee back on. We're gonna we ain't gonna do it too soon. We gotta let this episode marinate because you put a lot out there. But yeah, we definitely got to have you back at some point. Like I said, I always appreciate you coming on, spreading your knowledge and your work and letting us know what's going on in the science part of the world. Yeah, I mean, this was a amazing part 2. I appreciate you. I'm gonna let you go, and you have a blessed night.
Yeah, you too. It's been great talking to you.
All right, this was another great episode of Catch Dog Concepts. Y'all finished the week out strong. Ushers open the doors. Mr. Ishee is out of the building, and so am I. Y'all have a good one.